Okay, so in the proof chapter of extension 2, here we are with chapter 2 review, question 10. Show by expanding that if n is odd, this particular expansion. Okay, so given that n is odd, n minus 1 obviously is even, so which is a way of saying that if we take the right-hand side, we've got x times x to the n. Well, I can use the magic of technology to cheat here. That you're taking x, you're taking x times this term, and then you're adding 1. That's maybe next line. We're adding 1 times that term, yeah? X plus 1 of those. Okay, which is what? Well, it's x to the n minus x to the n minus 1 plus x to the n minus 2 minus x to the n minus 3. That's what you're doing. You're adding 1 to each of these powers here because you're multiplying it by x to the power of 1. And then plus ellipsis plus x cubed minus x squared plus x. And then the other term, you're adding x to the n minus 1, subtracting x to the n minus 2, plus x to the n minus 3, plus ellipsis, plus x squared, plus ellipsis, plus x squared minus x plus 1. And I'm hoping you can see for yourselves that all of these terms in the between there add to 0, leaving us with x to the power of n plus 1. Now, that works if n is odd. If n is not odd, it's a bit trickier. It's not completely unfactorizable, but it just gets complex rather than this works for real numbers here. Okay, great. Okay, and then B, hence prove that if n is odd. Okay, so, well, 2 to the n plus 1 is going to equal 2 plus 1 times 2 to the n minus 1 minus 2 to the n minus 2 plus plus 2 squared minus 2 plus 1. I'm just substituting for x equals 2 right there, which equals 3q, well, equals 3 times that, where that is an integer. 3 times that, 3 times that. Well, it might be easy to say note that is an integer. Now, quite clearly, for positive integers n, or rather positive integers n larger than 1, that is an integer, that's an integer, and so therefore 3 divides 2 to the power of n plus 1. Great. Then 2 to the mn is divisible. Okay, right. Okay, let's yeah. So what have we got? It's probably helpful to keep this down here as well, within easy, so I can easily consult it. So 2 to the n plus 1. So what are we doing? So we've got 2 to the mn plus 1 equals, well, what does it equal? It equals, so there we go. It equals, it took me a minute. This is 2 to the m to the n plus 1 equals 2 to the m plus 1 times 2 to the m to the n minus 1 minus 2 to the m to the n minus 2 plus plus 2 to the m squared minus 2 to the m plus 1. Clearly this note this will be an integer if m and n, well, n's going to have to be an integer larger than 1. N is an integer larger than, and n is larger than 1. And if n equals 1, that works out. It's just 1. But if n is larger than or equal to 1, so it's got to be a positive integer. Now, earlier we said for n is odd, we need, so, well, n is odd. I think they mean clearly odd positive, okay? It can't be a negative. This doesn't work with n negative. Well, I actually haven't really thought about what happens if n is negative there, but I don't think that doesn't make any sense because obviously this here is the sum of powers where, x to the 0, x to the 1, x to the 2, proceeding to x to the n minus 1. So it doesn't work. That's obviously doesn't work for n negative. So they mean n is odd positive here. It's probably worth adding to that condition there. We're also going to need m being an integer there. Probably one of these exercises where they say just assume that, it doesn't actually say it there, but the intention is to assume that that the variables are integers in these exercises. Divisible by 2 to the n plus 1, you're obviously talking about the divisibility of numbers here, which is to say the divisibility of numbers really only applies to integers. And so you're going to need m to be an integer for 2 to the n plus 1, or m to be a positive integer for 2 to the n plus 1 to be an integer. I've probably talked enough here. I'm sort of talking in circles, basically. But if n is a positive integer and m is also a positive integer, then that's true. Therefore, 2 to the m plus 1, 2 to the m plus 1 is going to divide 2 to the mn plus 1. Okay, sorry, that's took a little bit of twists and turns there. But the expansion, I think, was the key thing that was getting in your way. Once you've done that, then basically substitution into that result is relatively straightforward.